Can anybody send a message on the chat informing everyone to, please be on mute because I'm giving me.
Shivanshish, you're not on mute.
Sir, please mute from your side.
Hey, Devasis, can you mute your side, please?
Yeah, I have muted everyone, but I don't know. I think they can actually unmute themselves. Let me check. Can anybody ping on the chat, please? So that my Zoom.
I have ping. I think you are able to see. I have ping already.
You did?
Yes. I you are able. Everyone I have ping everyone.
All right. That should be good then. All right. So here I discussed only about these 5, right? EIGRP, OSPF, BGP, VPN, infrastructure security, and troubleshooting I did not mention because as and when we are going through this protocol, EIGRP or OSPF or BGP, we will look at how to troubleshoot them then and there. Okay, we'll not keep the troubleshooting as a different topic. We'll just see how to troubleshoot or how to, work around and bring up OSPF or BGP or a VPN then and there. Okay, we'll not work on it separately. As and when we learn the concept of EIGRP, we will be going through that. So this is the basic topics that will be covered in NRC. So basically, since this is all about routing, right? You know that NRC is just about routing, right? So let's start with what is routing, right? Let's start with the now let's take up routing as our subject. So basically, what is routing? You have a message, right? You have a message. This message is encapsulated or hidden inside this envelope. You want to direct this message. You want to direct this message to some street address, some city, some state, right? You want to direct this envelope, which is having a message, to some city, state, and street. That is actually called as routing. Even in the network domain or even in the networking, when you consider a router, so when I say routing, what is the device that actually does routing? It is our routers, right? Routers are capable of doing routing because they are L3 devices. Layer 3 devices means they work on the IP layer. By now, I guess, right? By now, you should be aware of the 7 protocol layers. Am I right? So guys, are you aware of that? 7 protocol layers?
Yes.
Okay, awesome.
Yes, sir.
Awesome. So this router works on a layer 3 IP layer. Now let's say there is a router to router communication. Let's not say router to router. There is a message from a computer sitting behind this router.
Yeah.
This is a message, right? It has an envelope. It has a message. Now this one has a message to 10.1.1.1, or maybe just for now, let's not take an IP address. Let's randomly say it has a message to R2, or let's say PC2. Instead of R2, we'll say it has a message to PC2. Now, when this envelope enters this router from this PC, now it is very basic. You might ask me, how does the message enter the router? Some people might be confused with that. Some people already know the answer, so they do not want to waste time, but I'll still tell you it is directly connected to this router with a wire or through a switch in between, right? So obviously, whatever you send out of a computer reaches here. Okay. Now, when it reaches here, the function of the router, what is the function of the router? The main function of the router, remember this, first one, when a message comes to the router, for humans, whenever you talk about humans, what is a message? Message is written in a letter, correct? It will be written in a letter or it will be written in a document, right? But for computer machines, right? For computer machines, the message will be in the form of a packet, IP packet, right? Now, what is an IP packet? Just like how humans are reading a letter, it will have the address of who has written this, like from and then to. Similarly, IP packet also will have who is the source of this, to whom it is destined to, source and destination, right? And it will also have the message, and it will also have something known as TTL, time to live value, right? Now, you can ask me, what is a time to live? Eventually, in the concept of routing, while we are talking about the routing, I will explain you about the TTL in depth, but for now, understand that whenever a PC generates a packet, this packet should not keep roaming from router to router. Let's say there are 1,000 routers connected. For example, you know the internet, right? It has 1,000 or more than 1,000 routers, more than 1,000 networks. Once the packet starts from a computer, it should not be roaming everywhere. After a time, it has to expire, it has to die, right? That is known as time to live. You have to only live for 64, means after jumping from one router to another, one jump is known as 1 TTL, right? After crossing 64 routers, your time is done. You have to die. So every packet is having TTL. TTL means time to live. Where does it have this time to live? By now, CCNA, you would have done, all you guys would have done CCNA.
Till that next stop means last two to 5 next stop, that will be the life. After that it will come.
Sorry?
And yes, I'm saying like the TTL means like 64% means it will like live till 64 hops. After it will, and maximum it will go to 625.
नाही अरे राहू
एवढं
दे.
तरी करू
ते काम ते टायर
झालंय
झालंय का नाही ते
तोपर्यंत-
बघू दे.
तयार होतो बरं नाही उघडलं चांगली गोष्ट आहे असं मी म्हणतो तुला मग घरी जायची गरज
Yes,
नाही
I think
दोन्ही काम
there's
ऍट
a
अ टाइम
lot of noise in the
गावात
background.
जाऊन परत स्टेशनला
Not able to.
तेवढं वाचते का तुला घरी जाऊन गाव त्याला परवडत
Guys, can you please put
यायचं
your
की परत गावात.
कशाला
who is that
Yogesh,
speaking?
could you
पॅन कार्ड
mute, please?
झालं तुला यायचं बरं का? तू दळणार नाही का
Who is speaking?
Yogesh,
Not able to see his name.
Hey, Yogesh, can you mute? Yep.
Hello.
Yeah, good.
Hello.
Yes, I can hear you, Rahul. Go ahead.
Yeah. Since थोड़ा लेट हो गया, sorry sir. Hello.
Go ahead. Tell me, you wanna say something?
रिवाइज कराएंगे सर एक बार दोबारा से सर, थोड़ा सा लेट हो गया था सर मैं.
No problem. You will get the video recording. So, what we can do is you can go through the video. If you do not understand, please reach out to me individually. But revise definitely. If you don't understand, I will revise. But it will be very late for these guys if I just start revising again. So I'll just proceed further. If you don't understand, you can reach out to me personally. I'll explain it to you again. Okay?
Okay.
Yeah. All right. Yeah, that's right. Somebody told me that it is in the IP packet header. What is a header? Every message has a data. Message is nothing but your data. Before your data, there is a header added. What is the header? What is the source? What is the destination? What is the time to live? Right? This time to live actually stays in the header of the IP packet. It will tell you for how long a packet is or kept alive, right? So whenever PC1 here sends an information to PC2, right? Whenever PC1 sends an information or wants or generates, it has already generated an information to PC2. This router first will check what? The first thing it will check is TTL. Why it will check TTL? Because it wants to make sure if the packet that has come to this router, can it go one more step ahead? Does it have enough TTL remaining? Right? It will check that first. Right? Next thing, or maybe even before TTL, it will check if the checksum is correct. If the packet that it has received does not have any errors, right? There is a field called checksum. I will talk about that. But first, it will check if the packet that it has received is correct without any errors. Then it will check TTL also, right? Then it will check where is the destination of this packet. Now, in the destination, if R2 is the destination, then what does this router do? How does it know if R2 is the destination? I told you, not only has data, this message or this envelope not only has data, but it also has source IP, destination IP, TTL, checksum, and many other things in the header field. Through the header field, the router will come to know what is the source and what is the destination. If the destination is this router itself, right? If the destination was this router itself, this router will come to know this IP packet has my own destination. So let me check to which interface that particular IP address, destination IP address is assigned. And it will provide the envelope or message to that particular interface, right? But if the destination is for R2, the router will check its routing table. Why? Because always remember, the brain of the router is always the routing table. Similarly, for the people who have already learned CCNP Encore, CCNA, what is the brain of the switch? MAC address table, right? It will see what port number is assigned to what MAC address, right? Guys, are you aware of this?
Yes.
Okay. Okay. So the brain of the switch is your MAC address table. The brain of your router is nothing but your routing table. So it checks the routing table. How can I reach R2? To reach R2, get out of F0 bar 0 interface. Maybe if that is the thing found in R2, then it will send the envelope out of this interface. R2 once receives the message, it will check the destination IP address is nothing but this PC which is connected on this interface. Sends out the information. Now, who is doing this routing? That is this part. Means to go to R2, you have to, because there are several interfaces here, F0 bar 1 here, right? Here it is G0 bar 0 interface. But to reach R2, who told or who is written inside this router that to reach R2, you have to take or go out of this interface? Who will do that? Administrator. That is us. That is me and you, right? So if there are like multiple routers, R1, R2, R3, if any packet coming on this one, on this router, R1, I have to tell that packet how to reach R3, right? As an administrator, like me and you are administrators. Now, if we want to tell R1, that is this particular router, if we want to tell this router how to reach R3, what we'll do? We will add a manual route. Okay, we will say, if you want to go to R3, then first jump to R2, because R2 will be your next hop, right? In the routing terms, we write it as IP route. If you want to go to destination first, which is R3, and the subnet mask is so and so, like 255, 255, 255, 0, then first go to R2. This is the manual route entry or a static route added inside R1. Correct? Now, imagine you have told, now packet coming from to R1 wants to reach R3, then you don't have to worry because you have already told this router, if I have to reach R3, what should I do? It has to first jump to R2. You have already told this router, so you don't have to worry, right? Now, there is a packet coming here to this R3, but if it has to go to R1, again, you have to mention inside this router saying that if you have to go to R1, then the first you hop to R2. First hop is your, or the next hop is your R2. Right? But initially, when they found out something known as routing and routers, this is what the method they followed. They went into each and every router. They said, if you want to reach this router, please follow this path, right? Every human individually logged into every of this router and was writing a statement to reach so and so router, follow this path. But as and when the number of routers increased, it was a very difficult task for an administrator. Now there are only 10 routers or 15 routers. What if there are more than like 100 or 200 routers? Every time an administrator has to go inside every router and say, to reach so and so network, you have to go to the next hop so and so. Fine. He does that one time. Maybe you will hire 50 people, ask them to individually take care of each router. Again, what if there is a path change? Again, you have to do that, right? So this manual task of adding a static route was a tedious task. In the sense, it was very difficult on the administrators. Then that actually led to the discovery of dynamic routing. Dynamic routes. Now, what are dynamic routes? In dynamic routes, I don't have to get inside R3 and say that if you want to go to R2, follow this. If you want to go to R1, follow this. I just have to advertise this interface. I'll tell you what is advertising, or maybe you know also. Once we advertise the interfaces, the directly connected interfaces on the router, once you advertise them, they'll only discover who is my neighbor, who is connected to me. They will only discover who is connected to them. They will only discover. Once they discover, they will declare that, okay, this guy is my neighbor. Once they both declare that he is my neighbor, they'll start sending whatever is in the routing table, they will start sending to each other. Isn't it easy compared to the old method where the administrator had to go literally and put in the configurations? Right? This method was discovered for this reason, to limit the administrative tasks, right? To limit the human intervention. Dynamic routing led to the discovery of dynamic routing protocols. So if you want dynamic routing, you should also have that protocols which does that, right? Protocols or set of rules which does that. First, they found out something known as RIP, Routing Information Protocol. Then second, they were doing with something known as IGRP, ISIS. Then came advanced EIGRP, IGRP next version. Then they found out OSPF, which was even better. Out of these many protocols, even there are many more protocols as well, maybe few of them which I have not named.
BGP.
That's right. BGP is not a dynamic routing protocol. I'll explain you. Okay. So for now, we are talking about dynamic routing protocols, right? Now, here, RIP was the one which was discovered, and it uses hop count. Means I can one packet has a capacity of 15 hops. After 15 hops, the 16th one will be marked as unreachable. What if the router is connected after the destination is connected after 16 routers? Then RIP will say, no, boss, I'm sorry, I cannot reach it. Only 15 is the maximum that I can do. So there was some limitations, disadvantages of this protocol, which led to the invention of the other. Similarly, there was some advantages also of the EIGRP, disadvantages also, which led to the invention of the other. ISIS is also used now, right? In some organizations, they are using ISIS till now. It is a very good protocol. Similarly, it has its own advantages, disadvantages. For now, currently, EIGRP and OSPF are used in an enterprise level worldwide. Okay, you can see that ISIS is also used in a few organizations, right? But EIGRP and OSPF dynamic routing protocols are used worldwide in enterprise level currently, right? Tomorrow, I'm not sure which new protocol they will invent or which new protocol they will discover. But for now, these are the protocols which you need to work on, which you need to focus on. Okay. Once you know these protocols, you will be ready to work in your, enterprise level architecture. The first one among these that we will learn, as I already discussed, it would be EIGR.
ISIS no part, sir. ISIS. It's not
Sorry,
a part.
repeat that again.
ISIS is not part of this outcourse.
Right. So ISIS also has been used by some of the organizations. But now, as I would say, it is also getting faded. Right? It is getting faded. For example, on your phone, if you're using Android version, so for now you have the Android version 16 or 17. So if you were using Android version 1, who will be using Android version 1? Very rare, right? Nobody will be using Android version 1. So now they are using Android version 16. So
Sir, ISIs are mainly using by service providers like Jio and Airtel are using ISIs.
Exactly, that's right. It is
where they have ring kind of topology. They are using ISIs.
Not all the service providers. Some providers will be using. So basically,
Jio and Airtel are using, sir, still using their ISIs.
In India, you can find ISIS. It is not a surprise at all. But usually,
even I sir also saw this thing in the enterprise network. One of our client they reach means high-end device, Nexus devices, and ACI and HDA.
Even we have in our in our network. I work for Accenture. In our data centers, we also use ISIS.
Layer 2 connectivity and to make the free.
Definitely. So ISIS has, as I told you, has its own advantage and also has its own disadvantage. When you're connecting with any other networks, for example, I want to connect any other guys with ISIS, then that will be a problem, right? So if I am using in my own data center, it works fine. But when I have connecting it to my branches with my headquarters, then that will be a problem, right? So it is, as I told you, it has its own disadvantages. But mostly you will find EIGRP and OSPF.
Yeah, it is ISIS is also depends on there's an extreme vendor, right? They're all the data center infrastructure. They only use the ISIS, not even like any other protocol.
Exactly.
So it depends on the environment as well.
Exactly. So data center's most suitable protocol is ISIS. For our Cisco syllabus, for NRC 300-410, we have EIGRP and OSPF, which is covered and which is also widely used, right? We can firstly start off with EIGRP, but before that, do you guys have any doubts still here? Are we good till here?
Yeah, I want to know. You told previous slide. There's a few packets that's intended to the router itself. So, like when we pinging, I know when you ping from the device to the router, you can ping that individual router, and that packet is intended for the itself, that router,
Correct.
or
So,
maybe the gateway. Is
correct.
there any other use case that we targeting? We are sending the packet to the router itself or not, besides of the routing protocol.
So we can assume that there is another
End user. Okay.
connected directly to the router. This has 2.2.2.1. So if I send a packet to 2.2.2.1, router will know that it is not intended for any other router, but it is on the interface which is configured in me itself. It is this packet is for me, but for a different interface. So it will look at the interface on the routing table and just guide the packet to that interface.
Got it. Yeah, that's what you mean. Okay, got it. Sure, yeah.
Yeah. All right. So I guess there is no other doubt. So let's proceed with EIGRP, which is our first routing protocol. So basically, EIGRP is one of the dynamic routing protocols, right? So let's take two routers. Right. Let's just assume that this interface is configured as 192.168.12.1 and the other one is configured with 12.2, right? Now, if I want to configure an EIGRP adjacency on router 1, I'll just have to simply say or start any EIGRP session on a router with the keyword router and then say EIGRP, router EIGRP. Always the router EIGRP is followed by the autonomous system number. And this autonomous system number can be used privately with any number inside your own organization, and it can be only used inside your organization only, not to any exchange with other organization, right? Having said that, the first step would be enabling the EIGRP protocol on your router. How do you enable a EIGRP protocol? Just by saying router EIGRP and with the desired autonomous system. Now, at this point of time, when you configure these command or this command, the first command, the EIGRP or this router will assume that, okay, I have a protocol called EIGRP configured in me, but no action taken. It also knows after the protocol is configured, it is not told to me what to be done next, right? The action of the router will be seen with the next command. In the next command, in the EIGRP, the next command, what you will do is you will advertise any of the network. If you have seen in your CCNA classes, CCNP classes, the next command is you are advertising the directly connected interface with a wildcard mask, right? Once you advertise this directly connected interface, the protocol EIGRP is designed in such a way that it will find where this interface is connected to. Then it will come to know that it is on fast Ethernet 0/0. Okay. It will start sending hello packet. Immediately, it will start sending a hello packet from that fast Ethernet 0/0 interface. What is the source address? Source address is obviously on fast Ethernet 0/0. This is the IP address configured. So source address is 192.168.12.1. What is the destination address? 224.0.0.10. Now, why the destination address is 224.0.0.10? Because all the EIGRP configured router, whatever the routers which are configured with this statement, they listen and send packets to this particular IP address. So you have any update only for EIGRP routers, then you send it to this address. All the EIGRP configured routers will be able to hear them or listen to them. That is why this is used as a EIGRP multicast address. Right? No confusion still here, right? When the destination is used as 224.0.0.10, it will be sending this as a hello packet to 224.0.0.10. Now this hello packet on the way, if you can see that this hello packet is directly connected. This interface F0/0 is directly connected to R2. Right? Now R2 has not been configured anything as neighbor, or it has not been told that you are configured with router EIGRP. So it will just discard the packet. Why? Because there is no EIGRP configured on R2. So it will not be listening to any packet that is coming to the address 224.0.0.10. But if you decide to configure router 2 it will start listening to 224.0.0.10 now. And if you advertise the directly connected interface, now this will also start sending a hello packet. Right? Now let's talk about one hello packet. Now this packet comes here. This hello packet comes here. R2 finds that I am receiving something on 224.0.0.10. Then R2 sees that this guy, the source is this guy, 12.0. Let me check my routing table and see where is 12.network connected to. R2 will check its routing table and find that 12.network is directly connected, right? It is directly connected. So what R2 will do, it will send an acknowledge as well as a hello, right? It is not a acknowledge, but it is an update. Sorry. It is a hello plus a update. Once it sends an update, this guy will acknowledge and he will also update. Now, what is this update hello, update hello? Hello is nothing but making sure that there is a neighbor on the other side. Whenever you configure any router with any protocol, it will send a hello packet to the multicast address. And the other router, which is directly connected, receives that particular hello packet. It will also send a hello, right? It will also send a hello only in case where that sender, that is this guy, 12.1, if he is reachable only, if he is something, if you receive a hello from 45.1, and in this routing table of R2, if you do not have 45.1, obviously there is no point in sending the hello packet backwards, right? Because I don't know where is 45.1. How can I send it, right? So now in this case, I got a packet from 12.1 and I see it in my routing table. I'm sending the hello back, and along with the hello, I am also sending update. What is update? Whatever is in my routing table and advertised in EIGRP, I will send that guy. So in order, I am trying to help him know the networks which are connected to me. Is it clear till here? Any confusions? I'll take that as a yes.
Sir, R2 will do multicast or R2 will do unicast, sir?
R2 will do unicast.
Unicast.
Yeah.
Okay. Then, sir, the EIGRP packets are only hello, update, acknowledge, and update, or there are some other packets that are shared between these routers.
There are some other packets also. So what if R1 do not know about any network? Suddenly it loses a network. So it has to query, right? So there are query packets, reply packets as well, right? So query and reply packets, we will learn about it a little later. But for now, we'll just know that the different packets that we have learned are hello, update, acknowledge.
Okay, sir.
So this is the process of EIGRP neighborship. EIGRP neighborship looks very simple, right? We do not have any problems in neighborship. You just have to remember this. Hello, update. Then you will have acknowledge and update. This is the process of EIGRP neighborship. Now, when you want to take a look at EIGRP neighborship, it is very simple, right? So first thing, so this is the troubleshooting part that we are learning, okay? You can do a debug EIGRP packets. Now, what does this statement on the router do? When you say debug EIGRP packets, let's say even a hello packet that is sent will be displayed here. Okay, R1 is now sending a hello packet. Okay, received a hello packet from R2. All the course of action that is happening between the routers are listed. Those messages are listed. So you can see all that is happening, right? That is how you actually troubleshoot any network. So based on that, so if you don't receive hello packet from any interface, for example, F0 bar 0, or let's say F0 bar 1, you're not receiving hello packets from F0 bar 1, then you will see that message. You will not see any hello packets from F0 bar 1. Then you will immediately, you can understand that maybe F0 bar 1 is not advertised under EIGRP. The next thing to know about immediately after neighborship is that we
Sir,
have
one thing I want to know, sir, what does this hello packet actually contain? What kind of information in it?
sure. It contains AS number, right? So these both are sending hello to each other. Okay. Now this guy says, hey, I am 192.168.12.1 and I'm coming from AS number 100. Okay. And this guy says, I am coming from AS number 90. If it does not match, right?
Then the packet will drop.
That's right. The EIGRP neighborships will not be established, right?
Okay.
And hey, I am coming from 12.1. My hold time, right? Hold
Okay.
time or hello time. Hello time is so and so. Hold time is so and so. Means once in 5 seconds, I will send a hello. Okay. Why does R1 sends a hello once in 5 seconds? So we both are neighbors, right? We both are neighbors and we have agreed on it. But to check if you're alive or no, I will be sending hello every 5 seconds. And if you don't reply for 15 seconds, I will consider you are dead. Right? This
Yes, sir.
guy, this router also has to match with that. If he says, no, I'll send hello in once in 15 seconds, this guy's dead timer is 15 seconds. If this guy's hello timer is 15 seconds, then it is a mismatch. Obviously, the neighborship will not be established. So, like this, AS numbers, hello time, hold time, these are few of the things that are contained in the hello packets that are exchanged between the routers, right? That are exchanged between the routers so that to establish the neighborship, these factors must match between each other. You got it?
Okay, sir. Thank you.
Right. Now, moving on.
I have one quick concern here.
Yeah, go ahead.
So R1 sent R2 to hello packet, right?
Mhm.
And there's one interface from the R1 side, another interface is the R2 side. But what happens if there's a 4 interface in the R1 and all 4 are advertised the EIGRP. Does that share the hello packet itself as well, or how it goes?
No, it's one and the same. I'll tell you.
Yeah, sure.
So let's consider this scenario.
Yeah, and there's a 4 interface in the R1.
So there are other 3
Yeah.
interfaces here,
Yeah.
right?
Mhm.
And this is R1, and there are other 3 interfaces here.
Yeah.
Now, basically what I want here from R1 and R2, my intention here is R2, whatever is connected to, with how many ever interfaces it has connected to many other routers on the other end, right? Similarly, the same goes with R1. It has many interfaces and it has connected to many networks beyond. But my intention here is all these networks, right? All these networks should be known to R1. All these networks, let's say R11, R12, R13, R14, whatever the computers connected here, should be known. These networks should be known to R1. So what I'll do, I'll establish EIGRP between them. Now, let's say that they have many interface also, but I will establish neighborship only with the directly connected interfaces, right? You might ask me why? Because once a hello packets flow from R1 to R2, the reply packet should always have the hello packet received from a directly connected interface, right? Now, if I say a packet is coming here, source is 12.1, destination is 224.0.0.10, right? That is the hello packet that you get from a EIGRP. You agree?
Yeah.
That is received here. Now, this router, if it has to respond, it will check where should I go to? I have to go to 12.1 because I have to reply to him. Where is 12.1? I shall check my routing table. 12.network is directly connected on this interface. Only then it will send a reply back, right? So I will always try to establish EIGRP between directly connected interfaces. No matter I am connected to several other interfaces. What I'll do is I will advertise this network also. I will advertise this network also. I will advertise all these networks. So all these networks goes as an update. Okay. All these networks goes as an update to R1 saying that I have R11 connected to me with 50 network, R12 which has 60.IP address, R13 which has 70.IP address. These other networks that I advertise in EIGRP goes as an update. They don't establish neighborship, but they go as an update.
Sir,
So-
it means okay, you please go ahead.
Yeah, my concern was here, like, so the hello packet is only exchange between the 2 routers or neighbor routers, not the local interfaces. Like let's say the router 2 has the 4 interfaces or 5 interface, right? But all the interfaces does not advertise hello packet or something because it's a local, right?
Every interface does advertise hello packet. Okay. So I think,
but not locally to the same router, right? It's advertised to the other router or neighbor router.
Correct.
Okay.
So if I advertise this network. This, let's say, this is 20.1.1.1. This is 30.1.1.1. Okay, this is 40.1.1.1. And let's say this is 10.1.1.1. This is 10.1.1.2. Okay, this is again, okay, 60, 111, 70, 111, 80, 111. Now here you are writing router EIGRP on this router. Okay, on this router you're giving the command router EIGRP with the autonomous number 10. Network. What is the network? 10.1.1.2, 10.1.1.2, 0, 0, 0, 255.
Yeah.
Again, network. I want to advertise this network also. Next thing, 60.1.1.1.1, 0, 0, 0, 255. Advertised. Next, network. 70.1.1.1.1, 0, 0, 0, 255. Done. This is the router EIGRP configuration on router 1. Next, router EIGRP. Same, 10. Okay. Network. 10, 111, 0, 0, 0, 255. Next, network. 20.1.1.1, 0, 0, 0, 255. Network. 30, 111. Network. 40, 111, 0, 0, 0, 255. Now, you can see that you have advertised all the networks or all the interfaces having that particular IP address. You have advertised them in EIGRP. It also means that you are sending hello packets out of these interfaces. Yes, it is true. It will send, once you advertise a network, let's say network 30. Let's take this as an example. Network 30.111, if you advertise that network in EIGRP, obviously there is a hello packet sent out. That is the rule of EIGRP, because what if you connect this interface to another router? You want that hello packet to be sent out, right? Only then this router will be able to discover this neighbor. If there is no hello packet, your other end linked router will not be able to discover at all. So there should be a hello packet exchange, right?
Yeah, but the hello packet from 30.111 is not sending to us the 20.111, right?
No, not at all. Okay.
Because it's a local interface.
Correct. And each
Okay.
interface is a different set. Okay. Each interface will send hello packet only to the other end of the interface. This is the other end. So you know that a wire has two ends. One end is this one, the other end is this one, right?
Yeah.
One interface, one slot is here, the other slot is here. In between is your wire. If you send a hello packet, it only has to reach the other end or the device which is connected to the other end, right?
Yeah.
That's just the way how it works.
So if, sir, my question is like, if,
Okay.
sir, my question is like here, sir, if multiple interface connected and say at a time same interface start to send a hello packet to directly connected interface. So might be the collision can create into the router. So what mechanism they are following up like to send a specific hello packet to a specific directly connected interface. Like here, three interface connected. Suppose any packet come from the 1.1.2 from the R1, and it's entering here, and again he required to go from the directly connected next hop. So definitely, whenever the packet will ingress into the R2, it will try to identify means where I required to. It will try to find where it connected. So what mechanism they will follow means which interface I required to send the hello packet and required to find, because in the same router there is a multiple interface connected. So how router and how they will identify means which interface required to go the packet. Because whenever the protocol we run, so direct protocol advertise all the things means this is my entities, this is my network, and they extend the database to the routers. So whenever new packet
So,
will come, so
when you say hello packet is exchanged, right? When I hear hello packet is going out here, because I have given this command network 10.1.1.2. So hello packet is going here. Network 70, hello packet is going out here. Network 80, hello packet is going here. Right? Now, my question is, when is the neighborship between the routers formed? Sending out hello packets is okay. Only if I say hello to you, it doesn't mean we are friends. If I get a hello back, right, means we have cordial relationship, two-way relationship, right? If any interface of a router receives the hello as well, not only sends the hello, but receives the hello as well, only then we can say these two routers are in a relationship. Only when they are in a relationship which is called as a neighborship, also called as adjacency, this is one word. Okay? Only when they are neighbors, only then they exchange the other routing tables. Other routing tables means now hello packet is sent and also received on this interface 10.1.1.2. Same goes with 10.1.1.1. It also received. So R1 and R2 formed neighbors here. Once they formed neighbors, now hello is gone. Forget about hello. Hello is only used to find if they are alive or not. Every 5 seconds, they keep sending hello just to find they are alive or not, neighbor is alive or not. But once they are neighbors, what is the message that is sent? There is an update message sent from R1. What in that update message, what do I find? See, R1 will say, I also have 60.1.1.1 network connected to my loopback 0. I have 70.1.1.1 network connected to my loopback 1. I have 80.1.1.1 network connected to my loopback 2 in the update message. So this is updating. If you want to know, reach any of these networks, 60, 70, 80, please reach out to me. Indirectly, it is saying, in this update message of R2 to R1, it will say, I know about 20.1.1.1 message. I know 30.1.1 message. I mean, sorry, networks. I know 40.1.1.1 networks. Please note that through this update message, it is saying to R1 that, please note that I am connected to 20, 30, and 40 networks. Now, R1 will make an update in the routing table or make a note in the routing table. I know about 20 network, I know about 30 network, I know about 40 network. But from whom? From R2. I know it from R2. It will make an update. R2 will also make an update in the routing table. I know about 60 network, I know about 70 network, I know about 80 network. But from whom? R1 is the next hop. If I want to reach these networks, I'll go to R1. Did you get it?
yes.
Okay.
Thanks.
So that hello is only sharing between the interface connected to one router to another router, right?
Correct. So
Okay.
hello
So
is the starter. hello is just before we are exchanging some personal information. Just assume it to be two humans, okay? Before they are exchanging any personal information between them, like their own routing table, which is in their mind, which is in their brain, they are just exchanging hellos between them. Once they have each other's hello, both should have hellos, okay? They should send and they also have to receive hellos. Once they receive that hello, they become neighbors. Once they become neighbors, they trust each other and send the routing information.
So, this hello packet does not cross the broadcast, right? It will stay within the broadcast, like the same subnet, right?
Correct. Yes, it will.
Okay.
So when you say within the subnet, it is hello packet is just sent to 224.00.10. 224.0.0.10. For example, right? This is a multicast address 224.0.0.10. Right? Hello packet is only sent to that address. For example, we are in a class, okay? We 25 people are in a class. CCNP Enarsi September batch. We are given a mail ID, September batch, Enarsi batch, and we are all in that. So if somebody sends a mail to that September batch Enarsi, who all gets the mail? We all 25 people will get the mail, right? Similarly, this 224.0.0.10 is only for EIGRP running routers. Whichever routers we configure with EIGRP, only those routers receive that hello. Nobody else will be able to get that hello packet. If a router is connected normally without EIGRP connection, it will not get that EIGRP message.
So in this case, can we have one more router on the 30 network, like on the side of 30, like 30.1.1.2?
Yes, we can have.
Yeah. And so my concern is, like, when 10.1.1 send the hello, does that hello receive to the 30.1.1.2?
No.
Not, right?
No.
Okay.
No. Because if you say this hello is only out of this interface. Okay. And this end of the interface is this end. The end of this wire is this one. Okay. It is received here. Right? This hello is received here. And this router, once it receives that hello packet, just imagine the status of this interface. Once it receives that hello message, what does it contain? Source, destination, right?
Yeah.
Now, destination is 224.0.0.10, right? Source is what?
So when it says, when you says the destination 24.0.0.10, it means there should be the interface as well towards the same interface, right?
No.
So that it will not go to the 30.1.1.2.
No,
because,
no.
I mean,
no, I'll tell
Okay.
you. I'll tell you that. So,
Okay.
hello packet is received from 10.1.1.2. You agree with that?
Yeah.
And when it receives here, this interface or this router will see that hello packet. The hello packet will be having source as 10.1.1.2, destination
Okay.
as 224.0.0.10. Am I right?
Yeah.
When the destination is 224.0.0.10, why will the router forward it to 30.1.1.2? It will not, right? So router always does packet forwarding only based on IP address. If the destination is 30.1.1.2, then the packet is forwarded to 30.1.1.2. If the destination is not 30.1.1.2, then the router will not forward it to 30.1.1.2. Now it will see the destination address here. It will see 224.0.0.10 multicast address only for EIGRP routers. It will check its own router. Am I configured with EIGRP? Yes, then it is for me. Then the packet is for me. It will accept the packet.
Mhm.
You got it?
Yeah, sure.
So likewise, whenever packet will enter, so first the router will check the routing table, then they will try to find where the destination is, and then that would they will forward that packet.
Correct. Yes.
Right.
For the
Sir?
normal packet.
Yeah, yes.
Excuse me, sir.
Yeah.
Sir, see now in in this scenario, if the 30.112 is established as a neighbor, it
Mhm.
sends an update to R2.
Mhm.
That update with whatever the interfaces are connected, will that also be sent to R1? Any in the
Exactly.
update?
Exactly. Yes, that's right.
Oh, okay. Okay. So basically, whichever is the neighbor, even though if it is after a couple of routers, if whichever is your neighbor, whatever update it gets, it will also be coming to the starting point also.
Correct. Yes.
Oh.
So basically, I mean, if this picture does not confuse you, I'll write another picture here. R1, R2, R3. So this is 10.1.1.1, 10.1.1.2. This is 20.1.1.1. This is 20.1.1.2. Now here, these two are neighbors because they exchange the hello packets. These two are neighbors. It is also R2 is also connected to 60 network. Here it is connected to 70 network, right? So it sent an update. I'm connected to 60, I'm connected to 70, sent an update. Now, these two also became neighbors. 21.1.1 and 21.1.2, right? And this has 100 network, 200 network. This was sent as an update to R2, 100, 200. Now, in the EIGRP routing table of R2, do you see this 100 network? My question,
Yes, sir.
right? You will
Yes, sir.
see it, right?
Yes, sir.
Whatever
Yes, sir.
is there in the EIGRP routing table is also shared with other neighbor also. Okay. Until it is there in the EIGRP routing table, your neighbor is towards the left, your neighbor is towards the right, you have another neighbor here, you have another neighbor here, it doesn't matter. If this router has anything in the EIGRP routing table, sent by any router, doesn't matter. It is sent by neighbor 1, neighbor 2, neighbor 3, doesn't matter. If that particular network is in the EIGRP routing table, then that is shared with all the other neighbors.
Okay.
Got it?
Yes. Thank you.
Okay. Guys, any other doubts? Is it creating a confusion? Do I need to go slow?
No, sir, it's good. From my side, your flow is very good.
Okay. So if it is causing confusion, do you want me to stop it at this? If we proceed, do you feel it is getting confused?
No, sir.
Is there any limit for the number of neighbors?
There is no limit for the number of neighbors. I can do n number of neighborship. So basically, if you ask me what is the limit for the number of neighbors, I would just say that 48, 60, depends upon your router ports. How many ports does your router have? Right? It does only have like 10, 8, 12, right? So on all the 8, you are connected with all 8 routers, then 8 neighbors you can maximum have, right? A router cannot have ports like switches where you have, 60 port, 48 port. Router still has lesser number of ports, right? Depends upon the router ports, I would say.
But it has the limitation of the how many routers you can have. So like it's a 255 max, right?
Correct.
For the EIGRP.
That is right. We'll speak about that once we are talking with the, neighbor table, topology table. Once we go over that, we definitely
Yeah, sure.
will go over that.
Yeah, sure.
Right. Any other confusions? Are we all good till here?
All good.
All right. So, I think if it does not confuse you, we can proceed. Adding to the neighborship, we have some tables. First one is the neighbor table. What is the neighbor table? Neighbor table on a router, if you want to see a neighbor table, you just have to enter the command show IP EIGRP neighbors. Show IP EIGRP neighbors. Once you enter the command, it will list all the neighbors that a particular router has. For example, if you go on R1 and enter this command, show IP EIGRP neighbors, it will show that R2 is my neighbor. If you go to R2 and enter the command, show IP EIGRP neighbors, it will say R4 and R3, both are my neighbors. If you go to R4, you will find only R2 is my neighbor. If you go to R3, you will find R2 is my neighbor. Or if it is
So in R2, R1 is also neighbor, no, sir? In R2, I think there will be three neighbors like R4, R3, and
Correct.
including R1.
Exactly. Right. In R2, R4, R3, and R1, there are three neighbors. Right? In R3, we have R4 and R2. So this is the table. Remember this three tables. One is neighbor table. The second one is topology table. Right? The third one is routing table. These are the three tables found in all the protocols. Let it be EIGRP, OSPF, ISIS, RIP. You can find these three tables in all the routing protocols. These are the three main tables. So coming back to the neighbor table, it gives us a list of all the neighbors, directly connected neighbors for that particular router where you are entering the command. Okay, it gives us the list of all the connected directly connected neighbors. Okay, now what is the routing table? It is the list of the best routes to reach any particular destination. What is a topology table? List of all the routes to reach particular destination. Okay. Now, if you are clear on the neighbor table, so are we clear on the neighbor table? Neighbor table is the list of the neighbors. It gives us the list of neighbors.
Directly connected routers.
directly connected neighbors. Okay, so in EIGRP, OSPF, and any dynamic routing protocols, the neighbors are always directly connected. Okay, keep in mind, the neighbors are always directly connected. There are no indirect connected neighbors. Okay, you cannot form neighborship with R1 and R3, right? You cannot. All the neighborship should be between directly connected neighbors. You know what is the meaning of directly connected? Because there is one link which is directly connecting R1 and R2. That is why they are known as directly connected neighbors. Okay, so neighbor table gives us the list of directly connected neighbors. Right? Now, moving on to topology table. Now, let's say R1, R2, R3. Right? Now we have R1 and R2 are neighbors. R1 and R3 are neighbors. R3, R4 are neighbors. R2, R4 are neighbors. Okay, all the directly connected ones. All the directly connected ones are neighbors. Now let's say that R4 is connected with a 40 dot network. 40.0, maybe let's say this is a PC or something, with IP address 40.0.0/24. Right? Now, if I go to R1 and say, show EIGRP neighbors, what will R1 say? R1 will say, I have neighbor as R2, I have neighbor as R3. Fine. Okay. Now, what if I go and say, show me the routing table? What is the EIGRP routing table? Means once you exchange hello and become neighbors, your neighbor will exchange some routes with you, right? Your neighbor will exchange its routing table with you. For example, R2 is connected with a 20 dot network. This is the routing table of R1. In routing table of R1, we have first line 10 dot network, and it will say directly connected. See, it will say directly connected. Then the second line will say 20 dot network. And how do you know 20 dot network? Is it directly connected? See, no, it is not directly connected. It is gotten from R2. R2 sent me, after we became neighbors, it sent an update message and sent me 20 dot network. Fine. Okay. Now, R3 also has 30 dot network. Once they both have become neighbors by exchanging hello packet, R3 will send an update message. Update, I have 30 dot network connected to me. Okay, fine. In the routing table of R1, there is a new addition, 30 dot network information. How did I get 30 dot network? From R3. Done. Added to the routing table. Now R4, what it does, once R3 and R4 become neighbors, R4 will send to the routing table of R3. R4 will send an update. Hey, I am connected with 40.network. And obviously R3 will also send, I am connected with here also. R1 will also send, but we are just talking about R1 and R3 now. Okay, whatever they receive, I'm talking about. Okay. In R3 routing table, R3 will have 30.network. Where did it get 30.network from? It is directly connected. And 40.network also you will see in the routing table of R3. Where did it get 40.network from? 40.network was gotten from R4. Similarly, in R2 routing table, R2 has got 10.network. Where did it get 10.network from? R1. 20.network, where did it get from? It is directly connected. Where did it get 40.network from? R4. Right? These are the networks. Because once they become neighbor, it will send us an update. Okay. Now, if you can see here, R2 first only has sent 20.network. Okay. R2 has sent only 20.network as an update. Here. But in the routing table, EIGRP routing table of R2, there is another network that it just now got from R4. So it will send that also. It will not keep that as a secret. It will send that also. It will say, hey, I got another update from R4. It is a 40.network. But since I am sending you, you keep me as a next stop. So this router one will note down, I got 40.network from R2. Now, router 3 will not keep quiet. It will also say, hey, I just now got 40.network from R4. So you take it. So again, there will be another entry, 40.network, 54. I got this from R3. This I got from R2. This I got from R. Now you can see that in the routing table of R1, 40.network is obtained, is gotten. 40.network is available for us from R2 also, from R3 also. Okay? R2 also, R3 also. Now, what is a topology table? Topology table has all the networks. So now for 40.network, how many routes you have for 40.network? So if this R1, now R1 has a computer connected, that computer wants to go to 40.network. Either it can take a path via R2, because see here, if I want to reach 40.network, because the routing table of R1 will say, if you want to reach 40.network, go via R2. And the second path will say, if you want to go to 40.network, so if a packet is sent towards, if a packet is coming from this computer and wants to reach 40.network, packet can be sent in two ways. One is this way, second one is this way. Right? So that is the topology table. Topology table contains, for a particular network, it contains all the possible routes. Whatever possible way it has to reach a particular network, all that possible routes are contained in a topology table. What do you mean by that, sir? Then what is the difference between routing table and topology table? Consider routing table. Routing table will not list both of them. Either via R2 or R3. Which is the best one? It will calculate the distance. Distance via this to 40 dot. From this way, the distance is less to 40 dot network, or from this way, distance is less to 40 dot network. It will calculate. Only that best route is put in the routing table. But in the topology table, all the possible routes are listed. That is the difference between routing and topology table. For to show my handwriting, I'm so sorry. Show IP EIGRP topology. If you want to see for 10 dot network, how many routes are there? For 20 dot networks, how many routes are there? For 30, how many routes are there? How many routes in the sense? How many paths? For example, here you have two paths for 40 dot network via R2 and via R3, like that. Okay. For 40 dot network, how many paths are there? If there is only one path, topology also shows only one path, right? But routing table show IP EIGRP route. This is to see the routing table of EIGRP. This is to see the topology table of EIGRP. Whenever you do a show IP EIGRP route, it will again say, okay, you can also see 40 dot network, but not via both. It will calculate which has the least distance. Okay, R2 has the least distance. So that will be installed in the routing table. Only the best route will be installed in the routing table. Any confusions, guys? Are we clear?
Yeah.
Awesome. So those are the three types of tables that we have. To memorize or to revise again, it is neighbor table, topology table, and the routing table. These are the three tables for every protocol they matter. Neighborship is different. After neighborship, after exchanging the hello packets, they are called as neighbors. Why? Because they both sent hello and received hello. So they are neighbors. After becoming neighbors, what they do? They update or exchange the routing table. What do you mean by the routing table? Show IP EIGRP route. Whatever networks are inside this EIGRP table. Now, you might ask me, sir, 40 network is here, right? Now, R4 also knows 40 network via two sides. R4 is connected to two routers, and here is another router. R4 also knows 40 networks from two sides. When it is updating to another router, which route will it update? Means I know R4 from path 1 or path 2. Whenever a router is updating to its neighbor, updating any particular route, any particular network, it is updating to its neighbor, it always advertises or updates the best route. Best route. always the best route is in the routing table. Right? Only
Best
the best
route, is it, I mean, best route to any particular destination?
Correct. Best route to any particular destination. Only the best route to any particular destination is advertised. So R4 also knows about 10 network, 20 network, 30 network, 40 network, let's say, right? This is R5, R6, R7. Now, when you ask me, it is updating 20 network, fine, because 20 it knows only by one way. 30 it knows only by one way. But 40 it knows by two ways, R5 also, R6 also. So 40 network, it will say, I know it only via R6. Only best path it will forward. Only the best path it will update for a particular destination.
Sir, like suppose whenever we are running the command and router, so I will never advertise it. So in that case, only the best route they advertising.
Correct.
And whenever running the receive routes from the never router and the same router, so only whatever the best route that one is receiving from there.
Correct, exactly. That's right. Okay, I think that's a lot of concepts for today. I don't want to I don't want to what do you say, confuse you more. I'll just leave it at this, right? So I'll stop it at this. What do you guys say?
Yeah, that sounds good.
All right. So I would like to thank everyone for giving your time for this class. Thank you for your time, guys. Have a very
Tomorrow
good
same
day.
time, sir?
Sorry?
Tomorrow same time class will be start. And this weekend class is 2 days.
Yeah,
no?
same time. So we'll connect on same time tomorrow.
And sir, I believe you will share the document for the content
Sorry?
of the course. You will share all the document of the content of the course.
I do not have content for this actually. So while I'm, while we are on the class, you can take the notes, I would say.
Now, sir, after completion the course, they will networking will not
Yeah, I
provide
think
the
they
videos of
will.
this thing.
Yeah, they will provide you some notes or something like that. I'm not sure, but you have to check with them.
So that require the documents, sir. So it will help in
Yes.
the other.
And also you can find the recorded videos also.
Yes, recorded video it will find, but after some time they will stop the access the recording, no?
Yeah, that's right. Yeah, recording will be updated, but I would say as and when you are on the class, I would say I think taking notes would be a little better. Would do better for you guys.
Okay,
So
that when we require to register because as of now they are asking the money, so might be they will share the free code. So then after putting the free code that will be activated, then we able to see that portal. Or it's not because that.
okay, I mean it doesn't take much time. Actually, it will be
But required the free code, no? We required to that from the help desk somewhere. Okay, fine. I will check that in the packet.
Okay. Yeah, check and let me know if there is any problem. So let me know. I'll just speak to them. Okay.
Okay. Thank you, sir.
Thank you, everyone. Have a very good day.
Thank you.
Yeah, thank you, Rao.
Thank you. Bye.